Good morning, good afternoon, or good evening, depending on where you are. This is Tom Layden, VP of Marketing with Excelero. Welcome to the second Excelero webinar of 2020. I only have one speaker for you today, but sometimes that's all you need for a really good webinar. So we're very thankful that our CEO, Lior Gal, cleared some time from his calendar to give us an update on NVMe, storage, the data center market trends, and Excelero successes with partners and customers in general. We've seen a tremendous amount of innovation in the storage space over the past 5 years, particularly in the NVMe space, and Excelero, led by Lior, has been a thought and innovation leader in this space since the early days, and we've witnessed the NVMe revolution on the forefront. So Lior has plenty of great insights for you. Before I hand it over to Lior, here are some logistics. We want this webinar to be very interactive, and we would like to get as many questions from you guys as possible. And this is how this will work. Everybody but Lior will be on mute, but at the bottom of your UI, you should see a Q&A button. Post as many relevant questions as you want. We have a team of specialists ready to answer those questions in real time, but the best questions I will save for the end of this webinar, and then we will ask them to Lior so he can answer them for everybody. And at that moment, you can still post more questions should you have any. With this, Lior, the floor is yours.
Thank you, Tom. So again, good morning or afternoon or evening, everyone. I appreciate you guys taking the time to attend in these interesting times lately. And hopefully for the next 30 minutes, you'll get some refreshing information that will take your mind away from the day-to-day news. At least I'm not going to watch the news anytime soon. Agenda-wise, what I want to cover is, for the ones who don't know us at all, talk a little bit about our vision. Why did we start this journey almost 6 years ago? About the execution, and it's the state of the union for us. You know, where are we today? What's working? What are we seeing that customers and partners are appreciating? And then a touch on technology. I'll add a quick spoiler. The technology session will be in the next few weeks, another webinar with our CTO, but a touch of technology to explain what makes us so special. How can, having a vision and executing on business is not enough without the ingredients of the technology itself. And at the end, talk a little bit about what's coming next and the future. So vision. August of 2014, when we incorporated as a company. That year, at least for me on a personal level, I was a global VP of sales of a storage company, selling into what we're calling today the hyperscalers, and selling appliances while the public cloud market starting building up. And it was clear from everything that this is going to change. And people will try and phase into what we're calling today a more cloud-like infrastructure. How can I buy the cheapest, easiest hardware, commodity hardware, and use software-defined data center? So that was back then something that I decided, at least on a personal level, on the business level, that I want to disrupt. And then partner with 3 other co-founders, the brilliant minds, the technologists, which really looked at the NVMe market and NVMe over Fabrics market before NVMe over Fabrics was even called that way. And together we came out with the idea that this is the time to transform the way data centers will service storage. In a way, storage, at least for me for the past 20 years, was always something that created a conflict, an issue. How do I build the right storage infrastructure to support my app? And when the app changes and the use cases becomes more demanding, what do I do? How do I change and how do I retrofit? We thought that with the new technology, we can just make the storage no worry, no issue at all. And we will let people run whatever they want to run, any use case, any performance requirements, their way without worrying about storage anymore. And that was the vision back then. And that vision was also based on the fact that we looked at something that always happened with time. If you look at the way things are being deployed, databases, what we're calling on this slide, enterprise IT, that was always the demanding storage use case. So that was true back then as well, 6 years ago. The need for low latency, the need for high throughput, great, right? So NVMe can do all that. And then AI started becoming bigger and bigger. Now we're looking at AI-driven workloads everywhere, starting from the cloud, hyperscalers, but really everywhere. So how do you service the most demanding use cases? So the idea in mind was that we'll create something that won't be a concern for any use case and will be able to work in a perfect and optimal way. So talking about building a solution and building a solution that will be optimal for any use case. The way we looked at the market back then, and that's the same way we're doing it today, was actually a split of two different methods. One was we want to partner with solution providers that will take a solution to market. They want to give their customers the best performance, reliability, experience ever, but they need to do it with also the best price performance. They need to do it in a way that will be able to, for customers to consume it. So looking at the AI market a few years back, as one of the markets that we have an hyper focus with, we started collecting those solution providers, started working with those guys who understand customer requirements and optimizing our software stack to be, at the end of the day, the acceleration layer that you use within a solution that is being sold to customers. So this example here, and I'll share some others later, STFC, it's a research center from the UK that bought a complete solution from one of our partners, Boston, but that solution, even though it included our software, never needed us to be in front of the customer. What our software did is accelerated the access between the GPUs, in this example, the DGX2s, to the NVMe storage in a way that just was so much better. For them, specifically 10 times better on price performance than any other option. So we're seeing that using our technology to accelerate solution providers to market so they can go and promote commodity hardware, our software and their services, the way they understand customers, is one of the leading ways to market. This ResNet 50 benchmark, which I won't go into many details here, is something that we did comparing it to any other solution in the market with the most innovative file system approaches you can think of. And the math at the end of the day, which led STFC and others to make that decision, was that with the Excelero NVMesh technology, you can get to the 10 times better price performance. Again, touch-free process, really based on solution providers, taking a solution to market. And in this example, Boston being a partner for the past 3 years. The second leg, which is also the way I started this webinar, second leg was really the way it all started. We said, okay, we don't want to be a Me Too company. A Me Too company that will create the best ever combination that will have a rack scale performance. And if somebody wants to use an AI use case, will be just fast. We said, okay, we want to do that, but we also want to do it on a cloud or data center scale. We want to be able to build a solution that will be used by the leading hyperscalers when they build their data centers. And for that, it can be one rack or multi-racks. It can scale up to a data center. So the same benefits, the same acceleration, reliability, same benefits that STFC saw when they checked our solution provided by Boston. At the end of the day, it's the approach of the best of breed. Customers can choose the best of breed servers, if that's Intel or AMD based, best of breed NVMe drives, best of breed networking. They choose their components, right? But when they look at storage, we want it to be that software that will be most accelerating, reliable technology that will be best of breed at any scale. So we have a few tens of projects at that scale, and this is a dashboard from one of those projects. And being a storage guy, first time I saw it working, having a vision and executing isn't really the same. A storage cluster should have tens of servers accessing that cluster. Maybe the biggest ones I saw go to 3 figures. This is 6,000 servers, 6,000 clients in one cluster, accessing close to 10,000 volumes. And the concept is, if an hyperscaler wants to build a flat namespace, wants to build a data center in a way where it can utilize resources the most efficient way without caring about which rack, which server has the resources, then it will be able to use our technology. And what's amazing about that is that our core message was the optimal performance at any scale. So performance at scale is something you will see coming out a lot from our messaging. Now, specifically here, but it's kind of the same with other projects, running hundreds of tests. I'll use a Corona example just because I'm in the office right now and the highway behind me is completely empty. When customers usually try our software, if they try it on an empty highway, meaning there are no concerns at all, you have the network, no other competing use cases, no other competing resources, just try and see how fast it can go. Many products can go fast when there are no concerns, many products. But what our customers are testing us for, and this was a great example, is let's change the block size. Let's change the ratio of read and write. Let's try to figure out what happens when you try different failure scenarios. And what we did for the past 6 years, our team, which I'm always saying, a deep engineering team with 20 patents plus behind us, what we did was to create a product that will work with optimal performance, with optimal efficiency and reliability, with all of those concerns happening at the same time. So you're in New York, no coronavirus, middle of the day, bicycles, taxis, people walking the street, you can still go on optimal performance. And that's what makes us unique, lean and mean. Now, the bigger picture of the global activity that we did, and what you can see on this slide is probably, again, out of our global partners, these are our leading 3 global partners, Dell, Lenovo, and Supermicro. And on the right side, you can see names of customers, production customers that bought our technology from them as a solution, right? So really, if you're a partner listening to this webinar, you are really, our first line of customers, excluding the hyperscalers, because what we allow partners to do is to build a solution that will win while competing against any other solution in the market. If it's companies like PathAI, or in the cancer research space, or supercomputer in a solution in Cynet in Toronto in Canada, all the way to Deutsche Bank, who's been using us for more than 2 years for reporting, for daily reporting. So these are all solutions sold by our global partners, and we're in the process of onboarding more. Just recently signed QCT, and that's the way we see it is the best path to market. Because with respect to our technology, at the end of the day, customers are looking to buy a complete solution, and a complete solution can be delivered better by global partners. Now, looking at the regional ones, this is where the magic really is. If we have 3 or 4 global partners, and as you saw, that are selling into many places, some of them are partnering with the same regional partners. You're seeing the same name, PathAI, slide after slide. And these regional partners are the ones that really understand the customer requirements. They really understand their space. And our focus with them, as you can see from the title, was the AI market, was feeding GPU storage the most efficient way. And we started collecting those for the past 2-3 years. And I'm saying collecting because we had to selectively choose the right ones, the ones that are already pushing to market innovation. NVMe drives, fast networks, looking at NVMe Fabrics, the NVIDIA distribution partners, and Scan being one of the latest ones that has joined our family, a UK-based company. And these guys are just taking our solution while they build their combination, and when they sell it to markets, it's just unfair, right? Because they can take a simple server, a simple Supermicro server, with NVMe drives, use our software and convert it into a machine that can outperform any all-flash array. So just throwing up numbers with everything which is going on globally, since the beginning of this year, we've already won 12 new projects with end users with those regional partners. So this is booming, and this is an exciting thing to see. So pausing about business and just touching technology for a second. For the ones that did not have the time to visit our website or to speak with any of our team members before, really explaining what's so unique about our approach. And for that, you really need to look at where Flash was deployed 6 years back again, and where Flash is deployed today, and the different ways of deploying Flash. So everybody understands that if you take Flash and you use it as an in-server Flash resource, you're going to get optimal performance. It's in your server, it's on your PCI bus, nothing can be faster than that. Problem is utilization. Problem is the ability to manage it as a resource. And back then, when we started exploring our ways, people talked about 10, 15, 20% utilization of in-server Flash. So if you're already used to in-server Flash, if your use case, if it's AI GPU driven or database driven, if it's already using in-server Flash, you got hooked to the performance. So it's hard to move. It's hard to touch something that works and is that simple, even if the ROI is dramatically worse. And then the other approach, which is more the enterprise approach, which we never tried to compete against. Other approach is the all-flash array. So choose your favorite vendor. It's take the same drives, put them in a storage controller, and now there you go. You can share it. You can offer data services. You can offer reliability. Problem is, you take performance and you throw it out of the window. The reason is simply because you're locking those NVMe drives or caging those NVMe drives with this approach behind the controller. And the follow-up slide will share some examples of what does it mean to cage very fast NVMe drives behind the controller. So again, you can't beat the reliability of this type of deployments. What we decided to do and what we have invested our time with NVMesh 1.x and now announcing and GAing NVMesh 2 is to give customers the benefit of the best of both worlds. We wanted to give customers the feel of local performance, the efficiency of local performance with all the enterprise reliability one would look for. So we talked about it at the huge example of 10,000 volumes in one cluster. But really the point is it's you install, easy to deploy. It does what it does perfectly. And it's a reliable storage solution, but it doesn't compromise performance. When you access storage, you're getting the in-server Flash experience. So that's what makes our technology unique, and the patents behind the way we did it and the way we're using NVMe Fabrics is what makes us so special. Now, saying special, again, not trying to pick on anyone. These are all official numbers from other vendors' website, but just using it to emphasize the point. So if you take the same exact hardware, here you can see it's an NVMesh, it's our storage operating system, NVMesh system with 24 NVMe drives. Take the same exact 24 NVMe drives with NetApp, or you take 24 NVMe drives with Pure. Again, amazingly good vendors with good solutions that we have nothing against. Because of the way things are designed, because our technology is client-side technology that doesn't require a controller on the storage side, look at the numbers. Just look at the numbers. 19 million IOPS compared to 1. That's 19 times better. And you know, throughput at 4 times the scale, or 3 times the scale, or 2 times the scale. And latency. So the latency is just outstanding. Local flash latency. So, you know, saying that we're better than 10x price performance will be just, you know, maybe too good to be true, but in some cases we are. The point is, you're buying, as a customer, you're buying that technology, which is commodity today, NVMe, fast networks, fast servers, multiple PCI lanes. We're going to give you the software to use it the best possible way, unmatched. Now, back to scale. It wasn't designed for one system. It wasn't designed for one system because there is no controller. It was designed for scale out. And yes, we're not the only scale out solution out there, but we're the only one who can scale the way we do with the same performance of a single system, meaning same type of latencies and linear scalability. And we've proven that again and again in clusters of hundreds of servers, hundreds of storage servers. So again, numbers, official numbers, and that's what makes us so unique for customers who are trying to get more, and also for partners who are building solutions so they can sell more value to their customers. Okay, so having said that, so what's coming next for us? What's coming next is that, and again, respect to the mess right now globally, and most of it in the States right now with the coronavirus, but we are moving strongly into 2020, and with that, this is the year for expanding our business in the States. We already have an office in California and offices in Frankfurt. Now it's expansion, mostly into the East Coast, but also bigger team in the West Coast, and also the first year that we're planning to do business in Asia, or to open an office in Asia. We already won few projects in Japan, few big universities with clusters of tens of servers. But we really want to go after the Chinese market where hyperscalers and the mass is there. So that's from that point of view. Partnership, we are, and again, for the partners on the call, we are 100% partner driven, excluding those hyperscalers that you can really, count on two ends, maybe in two legs. The rest of our business is all based on working with partners. And as I mentioned earlier, with my appreciation for the global ones, the regional solution providers. So if we have 20 roughly active right now between Europe and the States, actively selling every quarter to customers, we do hope to double or triple that number before this year will end. And a lot of plans that our partners should expect to get all of that to be able to deliver a better solution to customers. So that's roughly what I wanted to share. I guess I did it 5 minutes quicker than I had expected. I'm used to more interactive sessions. I must learn from that. But touching in a couple of words, our next webinar. So our next webinar, and I won't take the thunder from my partner, co-founder and CTO, Yaniv Romem, is to come and explain, where we are now and what's going to change moving forward. So if right now with NVMesh 2, we have the uniqueness of everything I've explained, including stuff like building erasure coding on cluster of tens of servers and so on and so forth. We have invested so much engineering effort in 3 spaces, which will become the topic of the next webinar. One of them is our work with NVIDIA, which you guys might know as a GPU Direct or the NVIDIA Magnum IO project. At the end, NVIDIA are talking about their DGX system, their GPUs getting 30% utilization from storage. Storage is a bottleneck. So how do you disable that bottleneck? How do you get to 70, 80, 90% utilization, the most efficient way, without any quality of service issues? So we are a part of that project with NVIDIA. And in the next webinar, we'll talk more about the technical details of what we're doing and what you should expect coming next. Second piece is something that we've been working with our partner Mellanox for a while, which are the smart NICs. For the ones who don't know smart NICs is a NIC with an ARM core on it, in a way, a computer on a NIC where you can run your software or offload our software into that NIC. What makes that unique is that we can transform from a Linux-only company to any operating system, any virtualization. But more than anything, the point is, once we fully embed on the smart NIC, and a lot of news coming later this year, customer gets a better experience where he doesn't need to install anything but the NIC. And we can also leverage all of the goodies and the benefits of the smart NIC to accelerate our features to market. And that's a huge, huge thing for us. And the last one with Intel is really opening that door. If I said it earlier, our customers are expecting to use commodity hardware and to utilize it the best way for optimal performance and optimal efficiency. QLC is giving you that, but QLC has some disadvantages. Combination of QLC and Optane, we've been working with Intel to get to a point where later this year, our customers will be able to use both technologies and get as good performance as TLC, if not better, using that combination. If you want to get more details, please join the next webinar that will probably be on the first week of May 4th. So that's about what I wanted to share today. And now I'll open it back to Tom and to questions, if any.
Yes, Lior, very happy that you finished a bit early because we're getting a lot of interesting questions. Folks, please continue to post your questions. I'm switching to having Lior answer them live because there is a whole lot of them and really good questions. So Felix was asking how NVMesh presents itself in the client machine.
Okay, so NVMesh, again, I'll give the explanation without going into too many technical details. And if you want to get more, please do reach out, sales@excelero.com or info@excelero.com. NVMesh is three major software components. One is the target side, which is installed on a server with NVMe drives and virtualizes those drives as a storage pool to allow us the efficiency and performance I have mentioned earlier. The second important one, which probably holds 90% of our IP, is on the client side. So what NVMesh is replacing the block driver on the client side, /dev/NVMesh. The IP, the smarts of the system is all in that driver. And that's the way it's presented in Linux machines. The third piece is the management piece, which is out of data path and is less relevant for that, of course. So it's a client target mechanism where the target does nothing but virtualizing the NVMe drive and the access to those drives. And the client does the multipathing, the RAID 10, striping, erasure coding, recoverability, and so on and so forth.
All right, Lior, you may have to pass on a few because I'm getting quite a bunch of technical questions, which really shows the need for having a webinar with Yaniv. I know you can answer a lot of those, so I'm going to ask you anyway, but feel free to refer people to the CTO webinar later on. So you answered the question on the client. We actually got exactly the same question on the target side. How is NVMesh presented on a target machine?
So I already answered that one in a way with the previous one, but again, on the target machine, a target machine can be a server with NVMe drive. The target software will virtualize the NVMe drive to allow remote access over the fabrics for those drives. And that's it. Once it's done, the target is out of data path, doesn't take any CPU cycles. A lot of the stuff we do is extremely efficient on CPU utilization to eliminate any problems with the noisy neighbor configurations if people are looking at converging compute and storage. And hopefully I answered that one. Any other?
Yeah. Then I have two related questions about the 19 million IOPS that you mentioned. One person was asking which data protection is used for that. And then another person was asking how many Mellanox adapters on the target side were needed to get to the 90K IOPS.
Okay, so with respect, I'll jump backwards to that slide. So it will be easier to, I jumped too quickly. It's good that it's recorded. So back to this slide. This server is a Supermicro Big Twin. I'm not trying to promote Supermicro, but the nice setup of having in a 2U form factor, 4 nodes, and each node has 6 NVMe drives. When you think about an NVMe drive, without picking on any specific vendor, and you think about the right balance and ratio between number of drives and a node, and when I'm saying a node is a server, but in this configuration, there are 4 servers in a way, 4 nodes in 2U, then you really don't want to exceed 6 NVMe drives. So it's 4 to 6 NVMe drives if all you care about is performance. So the reason why we could get to these high numbers is because these are 4 nodes, right? Because each node has the target software installed on it, and each node can give you this optimal performance. When you compare it to the design of the other vendors, it's a dual node approach where you have an interconnect link between nodes that needs to, cache mirror data or cache write data, before it's being acknowledged. And the interconnect link, which used to be a no-brainer and not the slowest piece of the puzzle, is now becoming the bottleneck. It can't do more than the million IOPS. So here, there is no need to do that. Data is written from the client. Once it's acknowledged, it's done, and then you can get maximum performance. Back to the node configuration, you want to have 2 NICs, 100 NICs preferred, 2 NICs for those 4 to 6 NVMe drives. And that's how you get to optimal performance. The last point was data protection. Clearly, if you're talking about random reads, our erasure coding isn't slower than our rate 10 or than anything else. So when you're reading data, you're getting the same performance. When you write data, if it's mirror data, you need to write twice, and for that, it's being cut in the middle. If you're writing data with erasure coding, there is a different, more complicated way to calculate it. But by the way, we do have a configurator on our website where you can choose the server, you can choose the number of drives, the number of NICs, the type of drives, the type of protection, and you will see what type of performance you can expect to get from that box. As simple as it comes. You should try it out.
Okay, and then I have a question that's related here. You're actually answering it with the slide, but still want to give it attention. Lexi was asking what the maximum number of volumes is that a mesh can support before you see performance degradation.
So I showed a slide earlier, and that slide was from one of our scale projects with 10 or 9,600 volumes in one cluster without performance degradation. I wish I could explain how we do that magic, but I let our CTO talk about it in the next webinar. 9,600. Most clusters out there are tens of volumes to hundreds of volumes. That's easy for us. So really, when you think, the message at the beginning, when you think about building your application use case or building your infrastructure, partner with us, don't worry about storage. Whatever the drives can do, whatever the network can do, whatever your servers can do, we'll give it to you, raw. And if you need more, it's linear scalable. Just add more, same cluster. That's the promise. That's the commitment. That's the type of projects we've been winning.
Okay, thank you. Another question I get here. Can you, that's from Babar, can you please briefly tell which remote storage protocols NVMesh uses?
Okay, so we, between the client and the targets, we use 2 protocols. One is NVMe Fabrics, right? So lately NVMe Fabrics is becoming more and more mainstream. And for people who are looking at using NVMe Fabrics because they just want to use the simplest, call it option out there, we support that. We also have a proprietary protocol which we're using, which is a variation of NVMe Fabrics. It just does stuff in a better way. But again, NVMe Fabrics. As for the different type of communication, with version 1, we supported RDMA, which is either InfiniBand or Rocky V2. With version 2, we also introduced TCP/IP. One should not expect to get the same performance, latency, and scale with different protocols, but the same cluster will support all. And we do have customers using all type of communication. So TCP/IP, Rocky V2, InfiniBand, choose your poison.
Okay. Thank you for that one. Lots of questions coming in here. We may have to take a few afterwards, even though we still have some time. James is asking what specific latency metric we can provide for a remote node. And then in particular, he's asking about Intel Optane, whether we would support less than 10 seconds of, 10 microseconds, sorry, of latency.
Okay, for people less technical like I am, the answer is quite simple. The overhead of NVMe Fabrics with these different variations is the 5 to 10 microsecond overhead. So the promise with solutions in our space and the commitment with Excelero is that we will add 5 to 10 microseconds. Again, depends on the data protection, the setup, and so on and so forth, to what the drive can do. So if you're buying drives that will have 80 microseconds of latency, add 5 to 10 on that. That will be what your application server should expect. That's simple, right? The second part of the question was Optane. So, again, the same rule of thumb will apply to Optane and was already, of course, already tested, approved, and supported. Optane is just so much faster and so much more resilience. It's still going to be 5 to 10 microsecond overhead for us to take an Optane drive, put it on the network, and share it between different servers. So instead of customers buying Optane and using them, that expensive resource, as a local resource to get the benefit of the performance of Optane or the low latency, with us, people can use Optane on the network and share them in a very efficient way. They will need to pay the penalty of 5 microsecond overhead, but other than that, it just became a shared resource.
All right. Always interesting to take a look at the competition, Lior. Dan is asking us how we compare to DDN's AI 400.
So I must admit, our customers don't, so I used to work at DDN, and I have a lot of appreciation and respect to what they do. But again, back to us, DDN are promoting their appliances. You buy it, small, medium, large. And if you need to move from small to medium or large, great. Buy a new system and replace it. Where we are really software approach to get, I would say, better performance and better efficiencies. Now to the question, right? We didn't do any head-to-head comparison against DDN, but we have few projects where customers did the comparison for themselves of how does it look to take Dell servers with NVMe drives and Mellanox networking and put it behind, as an example, a Spectrum scale or BGFS versus doing it with DDN. And what they saw was 2 to 5 times the performance advantage for the same price point. As an example, we don't require dual path NVMe drives. I didn't try to make it a technology session, but since a node can fail and our recoverability or availability is between nodes, our data protection is between nodes, we can have a node with single path NVMe drives, which are less expensive than the dual path NVMe drives. And we don't need the dual controller, which is more expensive than a single controller. So expect better performance, even against DDN, with respect, better performance for much better price performance, and the freedom to choose your drives, the freedom to choose the server you want to work with, and the lead time that you want to get from that vendor.
All right, thank you for that. Horatio is asking us whether we're hardware agnostic.
We are, as long as you plan to work with NVMe. So Excelero started with the NVMe tsunami of 2014, bad usage of words in this global crisis again, but we started with NVMe. Most of our benefits are using the NVMe features. If I would have talked about all the ingredients of what you can do with NVMe over Fabrics that you can't do with SSD drives or with HDD drives, that's what makes us unique. We didn't want to do another company who does an iSCSI protocol. We do have support for SSD drives, but even with that, I will argue that I would love to see our customers deploying us with NVMe technology because they will get the best for their money if they do that.
Good, thank you. Brian asks whether there are plans to implement Nonlong block erasure coding in the future.
Wow, painful. I guess it's one of our customers. Yes, this is not a roadmap discussion, but thinking performance, reliability, and scale, the first release to market of EC. And again, think about erasure coding on a 60 server, 60 node cluster working in optimal performance. It's not a 2-node erasure coding, a dual controller with RAID 6. So first approach was to make it the best way, and reliability was the key. Reliability and performance. We are coming out later this year. I don't want to say Q3 or Q4. I think it's more Q4, with the ability to use any NVMe drives for erasure coding, even the ones that do not support the long block. And the way to do that and the details can be shared under NDA, but we'll get the same performance, we'll get the same reliability with any NVMe drive before the end of 2020.
Okay, thank you. And sticking to erasure coding, an anonymous attendee is asking us how many CPU resources it takes on the client side when we are running erasure coding or compression.
Okay, we don't, so it's, I'm going to change my title at the end of the webinar to Acting CTO. Even though, guys, trust me, the CTO is much smarter, right? But first off, compression isn't there, right? We didn't, V2 product doesn't include compression. Back to my point earlier of using other partners, we're very tight to other providers, smart NIC market, to find ways to get compression by partnering with others and by using their capabilities. A general comment about the client-side resources. Again, I mentioned it before, I'll mention it again. A key design concept was how do we do all that without issues on performance, without making it noisy, without taking resources from the application, because at the end, our client runs where the application is, and if we take the resources, then maybe the storage works great, but there is no more CPU or memory resources for the app, so that's not really a solution. So with that, the design concept was with all the features onboarded, including EC, the design concept was not to exceed 2 times the overhead of the inbox NVMe driver. And if you guys know that, inbox NVMe driver almost doesn't take any resources. So I'll let the guy who's asking that question, please do follow up. And I let the chief architect or one of the others give you a better answer, but it's really as minimal as it gets.
Okay. Then there's a really great question here, and unfortunately it's technical, but I know you can answer this one. Good question from Glenn, who's telling us that he's seeing great performance on and utilization, but he's asking for recommendations on sharing data. So when multiple applications need to access the same data, how should customers take advantage of Excelero and get the best performance?
Okay, I'm going to try and spin it to a less technical answer because there is a message here. When we started, and again, I'm sorry to say that I've been doing storage startups and storage in general for 20 years. Love the space, but for 20 years. So when we started, we had a decision point. If we're going to build block, file, object, and thinking about the different spaces, we decided to go with the boring option. Boring option meaning we're going to go for block. Distributed block, the most efficient block, but we're going to go with block. And the reason is the block will usually or always sit behind the file system. Most of the cases with our customers, it's behind the local file system when they don't need to share, right? So behind the local file system, Excelero will accelerate the performance of the usage of NVMe and NVMe over Fabrics. Some of our customers are clearly looking at shared file systems. And for that, we did a lot of work with leading providers in the market, and sharing the names, Spectrum Scale, tens of projects, ThinkPark, BGFS, less projects, but also a lot of experience. We also hired the founder and creator of BGFS, a guy named Sven, to be our field CTO. And Quantum for the media customers, even though we have less emphasis on media. Just to be honest. So it accelerates other file systems. Why is that a business answer? Is because at the end, if customers or partners do not need to change their file system, if it's local or shared, do not need to change their file system to get 10x the performance and efficiency from new hardware at any scale, why should they? Changing a file system, and I used to work for file system companies, is a painful process. And it takes years, 10 years to build a file system. So we are in it for 6 years. It takes so much time to build a very reliable file system. So instead of trying to fight against the market, the decision from day one is we're going to work with the market. 9 out of 10 customers will not change their file system. We'll work with them. Not saying that we can't work with innovative new file systems. They just have a smaller market space and we need to stay focused. So that's the answer. Another one more angle, if I still have the time on that, is that lately we started doing a lot of work on shared block storage. Why is that? Because local file system, any file system, it takes a lot of the performance away if you start sharing it. with any file system, even the best file system out there. And the ResNet test I showed earlier, for some of our AI customers who are looking and experimenting with how they can get better performance, when we show them that shared block can get them to 10x versus shared file, that became interesting. But that by itself is a discussion that we need to follow up in a different time. It's too much for this call or for this webinar.
All right, thank you, Lior. I still have a bunch of questions here. I want to take one last one because then we're getting close to the end of our time.
This one, please give me one which is why.
Michael is asking us whether we support high availability configurations using dual ported drives and failover between two nodes.
So thank you for the business question. Much appreciated. Our GA product today can work with dual port NVMe drives, but it doesn't require the drives to be dual ported. It can work with servers with dual controllers, but it doesn't need the dual controller. So the answer is yes, it's doable. And yes, we have some customers who are using that hardware to use our software. It isn't required. It will make it more expensive and less logical for me to do so. But the answer is yes.
All right, good. And here's one more. Anonymous person is asking us the performance results for random write 4K workloads versus the read 19K that we showed.
I will take the fifth on this one, if I may. I don't have it in the top of my mind, and you know, I do want to leave something for Yaniv or for the follow-up after. So.
All right, and I'm seeing people already registering. We posted the link to register for the CTO webinar in the chat here. So please do register and bring your technical questions for those. And then anonymous person, unfortunately, I cannot reach out to you to answer that one off the record afterwards. If you want that one answered, please contact tom.laden@excelero.com or lior@excelero.com, and we will come back to that question after we checked with someone else. Let me just check if I had any more questions that need to be answered right here.
So maybe
yes, someone is asking why this is better than open source solutions on the market.
It's not better. I would say nothing is better. It's all relative to what people are trying to get. But taking the open source discussion aside, because an open source is also a business decision, do I want to work with open source or not? There isn't any other solution out there today that can get to our performance and scale. Some of the open source leading solutions, as an example, being promoted by Red Hat Ceph, can scale, but they will have 10% of our performance when they do scale. And other than that, you know, we have nothing against open source, fully supportive with that. NVMe Fabrics as a protocol is, of course, open source, and we're using that. There is, you know, that's what makes us unique. And maybe a closing statement if we're running out of time, because we did say a lot, but back to the first statement, it's all about transforming the way the data center work, allowing people, if it's hyperscalers for their own cloud scale, or if it's customers for their own data centers, use commodity hardware, get the greatest and best technology out there, and work with our software to make it the best solution for their needs. Starting from any scale, starting from projects as small as one server with 4 NVMe drives to a scale of thousands of servers. And that's what I think make us unique. And we'd love to share more, and we'd love to see more joining our journey, partners, customers. And I do really appreciate you guys taking the time and joining this Monday morning. And hopefully it was a good usage of your time.
All right, Lior, I thank you very much. You took a whole lot of questions. I would also like to thank the audience. It really shows that people have been paying attention, and I gotta say the show up rate was unseen. Thank you all very much. Please do register for the Yaniv webinar early next month, May the 4th. That is, it will be very interesting as well. If you have any follow-up questions, please do reach out. Any email that you can find for Excelero, tom.laden@excelero.com, Lior@Excelero, or info@Excelero, all works, all comes to us, and we'll take the time to answer any more questions as a follow-up. Thank you, everybody, and see you next time.
Thank you, Tom. Bye, everyone.